Yeah, good morning all. Now I am going to explain about power systems. Okay, this is very important topic. In this topic you will get around 10 to 15 questions. Okay, these are the very important questions. These are the backside bits of CL Wadhwa. Okay, in previous I think in 2015 around 15 questions they will given from this objective questions of backside of CL Wadhwa bits only. Okay, now we will solve the problems. Okay, what is the first question? The surge impedance of 50 miles long underground cable is 50 ohms. For a 25-mile length it will be, first option 25 ohms, second option 50 ohm, third option 100 ohm, fourth option none of the above. Okay, now see here the surge impedance value is doesn't depends upon length. Okay, surge impedance ZC is equals to under root L by C. Okay, that means surge impedance value depends upon inductance value and capacitance value, doesn't depends upon length. Hence the answer is 50 ohm only. Now see here ZC value is 200 ohms to 400 ohm for overhead lines. Okay, same that ZC value is 40 ohm to 80 ohm for underground cables. Typically for underground cables ZC value is 40 ohm. Typically for overhead lines the ZC value is 400 ohms. Okay, now the first bit answer is, see here 50-mile long underground cable is 50 ohms, right? Then for 25-mile length also it will be 50 ohm only. Okay, first that is option B is correct. Next, second question. For a load flow solution, the quantities normally specified at a voltage controlled buses are, first option P and Q, second option P and magnitude of V, third option Q and magnitude of V, fourth option P and delta. Okay, in load flow studies we are having four buses. Now you can see here. Okay, in load flow studies we are having four buses. First one is load bus, second one is generator bus or PV bus, third one is slack bus or reference bus, fourth one is voltage controlled bus. See here in this load bus specified values, first one in case of load bus specified values are P suffix P indicates real power, Q suffix P indicates reactive power. In case of load bus specified values are real power and reactive power. Unspecified values are magnitude of V suffix P indicates voltage and delta suffix P indicates angle. Okay, that means that is about load bus. Next, generator bus or PV bus. Okay, in case of generator bus or PV bus specified values are PP and VP. Unspecified values are QP. Q suffix P indicates reactive power, delta suffix P indicates angle. Now see here in the given problem what is given, voltage controlled bus, right? In case of voltage controlled bus the specified values are real power P suffix P and V suffix P, that is voltage. P and V is the answer. That is for second bus. For second question answer is P and V. Second answer is correct. Next, third question. For reducing tower footing resistance it is better to use, first option is chemical and ground rods only, that is not correct. Second option chemical and counterpoise only, that is also not correct. Third option ground rod and counterpoise only, ground rod and counterpoise, that is third answer is correct. Counterpoise is nothing but it is a wire, okay, that is connected between from tower point to ground. Okay, next, fourth question. The positive, negative and zero sequence impedances of a solidly grounded system under steady state condition always follows the relation. Okay, for a solidly grounded fault always positive reactance or positive impedance is greater than negative impedance is greater than zero sequence, right? Z1 indicates positive sequence impedance, Z2 indicates negative sequence, Z0 indicates zero sequence. That means Z1 is greater than, Z2 is greater than Z0. Okay, that is first option. Fourth one is first option is correct. See here, Z1 is greater than Z2 is greater than Z0. Next, fifth question. More relay is normally used for the protection of. Okay, more relay is normally used for the protection of. More relay used for the protection of long transmission lines. That is first answer is correct. Now see here. Now coming to the analysis. Majorly for transmission line protection, three relays are used: reactance relay, impedance relay, and more relay. Okay, reactance relay used for short transmission line, impedance relay is used for medium transmission line, more relay is used for long transmission line. See here, in case of short transmission line, arc resistance effect is high. In case of medium transmission line, arc resistance effect and power swing effects are moderate. In case of long transmission line, power swings are high. Hence, for arc resistance effect and power swing effects, we can use impedance relay. You can remember this point. This is also very important bit. Okay, next, sixth question. Reactance relay is normally preferred for the protection against. Reactance relay always used for the protection of earth fault relay. Sorry, that means earth fault protections. Okay. Next, seventh question. If the fault current is 2000 amperes, comma, the relay setting is 50% and the CT ratio is 400 by 5. Okay, then the plug setting multiplier will be, we need to calculate here plug setting multiplier. Okay, now the formula for plug setting multiplier will be fault current divided by, okay, rated ROC current into CT ratio. See here, from the given problem, the current flowing through secondary of CT is nothing but 400 by 5, right? That means the rated ROC current is 5 amperes. Okay, na? Rated ROC current is 5 amperes. Now I can substitute all those values in the formula. What is the formula? See here, plug setting multiplier is equals to fault current is given 2000 amperes divided by CT ratio into relay current setting. Okay, that is relay current setting is equals to relay setting into pickup value. Okay, pickup value here, pickup value is nothing but in the transformer CT 400 by 5 ratio is there, right? Secondary current is nothing but pickup value, right? Relay setting is given as 50%, right? Then relay current setting is equals to 50% is nothing but 0.5 into 5, that is relay current setting value is 2.5. Okay, then plug setting multiplier is equals to first fault current, right? Fault current value is 2000 divided by CT ratio. CT ratio is given as 400 by 5 into relay current setting or rated ROC current is also correct. Relay current setting, that value is 2.5, already calculated, right? 2.5 to the 5, right? That is 400 by 2, that is nothing but 200. 2000 divided by 200, that is value is nothing but 10. Then plug setting multiplier value is 10 is the correct answer. Now see the answers. First option is 25 amperes, not correct. B is 15, not correct. C is 50 amperes, not correct. That means the answer is none of the above. Next, this is direct question. That is, carrier current protection scheme is normally used for high voltage transmission lines only. Next, the ratio of reset to pickup current for an induction cup relay is approximately, this value is varies between 0.95 to 1. 0.95 to 1. From the given options, option A is 0.99, option B is 1.01, option C is 0.75, option D is none. Then the answer is A. Ninth one is A. You can check the answers. Ninth one is A, correct. Next, next question. The rotation of disk of an induction disk relay under the pole is, okay, See here, in case of induction disk type relays, okay, the rotation is always from unshaded pole to shaded pole region. Okay, that is first option. 10th one is first option is correct. Next, 11th one. If the time of operation of a relay for a unity TMS is 10 seconds, comma, the time of operation for 0.5 TMS will be, okay, the time of operation for 0.5 TMS will be, for this problem the formula will be time of operation of TMS is equals to TMS at unity is given as 10, right, into given time is 0.5, right, that is 10 into 0.5, that is 5 seconds is the answer. Okay, TMS as unity is 10 seconds, the time of operation is 0.5, then the new TMS is 0.5 into 10, that is 5 seconds. 11th one answer is 5, B is the correct. Next, 12th one. The shape of the disk of an induction disk relay. This is also direct question, that is spiral, SPIRAL. Okay, next. If the phase angle of the voltage coil of a directional relay is 50 degrees, the maximum torque angle of the relay is, okay, in case of this directional relay, the torque angle plus this theta is equals to 90 degrees. Okay, maximum torque, right, torque angle and phase angle of voltage coil theta, phase angle of voltage coil of a directional relay is assumed theta is equals to 50 degrees. Here we need to calculate torque angle tau. Okay, that means delta plus, sorry, theta plus torque angle tau is equals to 90 degrees. Okay, that is the condition. Okay, when theta plus torque angle tau is equals to 90 degrees, then the phase angle of directional relay is given as 50 degrees, then torque angle tau is equals to 90 minus 50, you will get 40 degrees is the answer. Okay, from the given options, first option is 130, not correct, B 100 degrees, not correct, C is 25 degrees, not correct, hence the answer is none of the above. Next, 14th question. Okay, a reactance relay is option A voltage restrained directional relay, option B directional restrained overcurrent relay, option C voltage restrained overcurrent relay, option D none of this. Okay, I can explain this point here clearly. Now see here, 14th one answer is B. Yeah, now see here, now you can observe this equation. This is the universal torque equation in case of relays. Okay, torque T is equals to K1 I1 square plus K2 V2 square plus K3 into Vi into cos of theta minus T plus K4. Okay, where first term indicates current unit, that is K1 I1 square indicates current unit, K2 V2 square indicates voltage unit, K3 Vi cos of theta minus T indicates directional unit, K4 indicates spring unit. Okay, in case of impedance relay, K1 is positive, K2 is negative, K3 K4 values are 0. Okay, to solve this equation, okay, K1 is equals to positive, K2 is equals to negative, K3 is 0, K4 is 0, right? That means always from negative to positive you can assume to know the value. See here, what is given here? Options: voltage restrained directional relay, right, directional restrained overcurrent relay, voltage restrained overcurrent relay, right. Now see here, from this equation, K2 is negative, right, K2 is voltage term, right, K1 is current term, right, K3 is nothing but third unit directional unit, fourth unit is spring unit. That means negative indicates voltage unit, right, first you need to start from negative, that is voltage restrained current. Voltage restrained over current relay, that is third one. Sorry, here he is asking reactance relay, right? In case of impedance relay, that is voltage restrained over current relay. Next, similarly for reactance relay, K1 is positive, K3 is negative, right? K3 is directional unit, right? That is negative. K1 is positive is current unit, that means directional restrained over current relay. Blindly you can remember reactance relay is nothing but directional restrained over current relay. Similarly, more relay is equals to, here K1 value is 0, K2 is negative, K3 is positive, that means voltage restrained directional relay. Now here it is a reactance relay, right? In case of reactance relay, yes, in case of reactance relay, it is directional restrained over current relay. Okay, next, the percentage bias for a generator protection lies between, this is also direct question, 5 to 10%. Okay, remaining we will see next class. Thank you all.